Hello, in this short video we are going to investigate the following challenging problem on the topic of evaluating definite integrals. The following integral from 1 to 2, absolute value of 2x minus the floor of 3x dx is equal to. Pause the video at this point and give it a try to see which one of the given following options is the correct answer to the problem. Let me remind you that for every real number a, the floor, this symbol is called the floor of a and is defined to be the greatest integer less than or equal to a. Okay, so let us solve the problem. You know that probably from your past experiences that if you want to solve if you want to compute a definite integral in which you have absolute value sign or the floor function sign, you have to decompose the integration interval into appropriate subintervals so that you can get rid of the absolute value sign, you can get rid of the floor sign. Okay, because of this 3 that you see here, it motivates me to break my integrals to intervals with length 1/3. Yes. And of course, if I do that, this will allow me to get rid of only the floor sign. But then I have to also be careful about the absolute value sign. Okay, I might need to break even those subintervals into more intervals if needed. Okay, but let me start from here. Okay, because of this factor of 3, so I will break this interval, which is from 1 to 2, to 3 subintervals, each with length 1/3. Okay, so I would say that if x is between 1 and 4/3, for example, then this means that 3 is less than or equal to 3x and less than 4. So in that case, the floor of 3x becomes 3. Yes. And if x is greater than or equal to 4/3 and less than 5/3, then I multiply everything by 3. Then it means the floor is 4. And finally, if x is between 5/3 up to 6/3, which is 2, then I multiply everything by 3, so 5 is less than or equal to 3x less than 6. Then it means that the floor of 3x is simply 5. And you shouldn't be worried about these one single point. So you know that in Riemann integral, just one point does not make any difference. Okay, so my question mark, I break my interval into 3 pieces. Okay? This is possible. Okay, but if I want to do that, then I will have to write 2x minus 3, 2x minus 4, and 2x minus 5. Okay? But then I will have the absolute value sign outside. Okay. If x is between 1 and 2, then it means 2x is between 2 and 4. Yeah, so let me even consider these things. So this means 2x maximally is 4. Okay, then it means that, and because the floor function is sometimes below the threshold, sometimes above the threshold, then I will have problems here. So, of course, it is manageable. You can write it and then consider the absolute value later. But if you don't mind, this is the general way to do it. But if you notice this inequality, that if I have a number a minus its floor, it is always greater than or equal to 0, but it is always strictly smaller than 1. If you notice this here, this will actually accelerate the calculation a little bit. So here, before jumping to here, I would say that this is integral from 1 to 2. Then instead of 2x, I will write 3x minus the floor of 3x motivated by that inequality. But of course, I have 2x, I have written 3x, I write minus x to compensate for that change. But then, according to what I told you here, this combination is always greater than or equal to 0 and is strictly less than 1. But x goes from 1 up to 2. Okay? So the minimum value for x is 1, but the maximum, the upper bound of this expression is 1. So this expression is always negative. So I can get rid of absolute value sign immediately. So this gives me integral from 1 to 2, okay? And I have to replace them. I have to take the absolute value away, but I have to multiply everything by a minus sign. So 3x minus x is 2x. When I multiply it by a minus sign, it becomes minus 2x. And this is already minus floor of 3x. Now it becomes positive floor of 3x dx. And now I break that integral into three integrals. Integral from 1 to 4 over 3. In that case, the floor is 3. So this becomes 3 minus 2x dx. And then plus integral from 4 over 3 to the next number, 5 over 3. And then this time the floor is 4. Yes, dx. And then plus integral from 5 over 3 to 2. But this time the floor is 5 minus 2x dx. Okay, but these are now elementary integrals you can calculate, but because we want to do it faster, if possible, so don't try to do these integrals differently. So in your head, decompose integral to two parts, 1, 3, 1 minus 2x, here 1, 4, 1 minus 2x, and here 1, 5, 1 minus 2x. Yes? Okay, so let me write it down for you. I think it's confusing. So I would write it in this form, from 1 to 4 over 3, 3 dx, the first one. I will take the first one from here, 4 over 3 to 5 over 3, 4 dx, and then finally from 5 over 3 to 5 dx. Okay, and I will do the same for the other term, but the other terms are all the same. So I can combine them back into one integral rather than solving it 3 times with working with fractions. Yes? So I would write it integral. So I will, first of all, I will write minus integral 2x dx from 1 to 4 over 3 minus integral from 4 over 3 to 5 over 3 2x dx. Again, minus integral of 2x dx from 5 over 3 to 2. But if between these three I factor a minus sign out, this becomes positive, this becomes positive. And now the integrand is the same. From 1 to 4 over 3, from 4 over 3 to 5 over 3, from 5 over 3 to 2. So this can be combined back again to 1 up to 2x dx. This is very simple. The primitive function is x squared. Goes from 1 to 2, so it becomes 3. 4 minus 1. Then I have to calculate this. But that one is also simple because this becomes 3. The primitive function is just x. 4 over 3 minus 1 plus 4. 5 over 3 minus 4 over 3. And then again 5. 2 minus 5 over 3. But all of these numbers are just the length of the subinterval, which is 1/3. So 3 plus 4 plus 9 is 12. 12 divided by 3 is 4. So this is also 4. So this is 4. This is 3. So I subtract them. So the answer to the question mark is 4 minus 3, which is indeed equal to 1. Okay, so if we go back here, we see that option 1 is the correct one. I hope that the video was helpful. Until the next video, be safe and goodbye. Thank you.